Right, question 10 is the investigation question. And it clearly says there, a student sets out to investigate how the current, so that's our one variable, in an electric circuit is affected when more resistors are added in parallel. There's our other variable. Now, before you even start this question, it's probably sensible just to get the two variables clear in your mind. I asked myself these two questions. Firstly, what does she change? Because that gives us the independent variable. And then secondly, what does she then measure? Once she's made that change, what is she then measuring? And whatever she measures, that's the dependent variable. So in this case, what does she change? Clearly she changes the number of resistors in parallel. So that gives us our independent variable. What does she then measure? She measures the current. And that gives us our dependent variable. All right, let's have a look at the questions. 10.1, an appropriate hypothesis. Remember, hypothesis is what we call a testable guess. So you guess at the relationship between the two variables. So you simply state the independent variable, and in this case, as more resistors are added, that's our independent variable. We then guess what the relationship would be, and in this case, the hypothesis will be that the current will increase. Remember always to give a hypothesis that you can justify sensibly with science. As you add more resistors in parallel, their combined resistance decreases, so you would expect an increase in current. 10.2 asks you to now state those two variables. The dependent variable we said was current, and the independent variable, the number of resistors in parallel. All right, 10.3, a list of apparatus, excluding the resistors that she'll need to conduct her investigation. She needs some kind of power supply, power source, or battery, cells, something like that. She needs an ammeter to read the current, and then she needs some connecting wire to join them all up. Okay, a simple circuit diagram to illustrate her setup. You'd need the power supply, the battery, or the cell in this case. The key thing here is to put the ammeter in series to measure the total current, and then I've just shown two resistors in parallel there and complete the circuit. Alright, the table of data is given and we're asked to write a suitable conclusion. So you have a look at how your independent variable changes. Well, our independent variable is increasing, 2 in parallel, 3 in parallel, 4 in parallel. And our dependent variable on this side, the current, clearly increases 0.3, 0.45, 0.6. So when we're stating a conclusion, we state our independent variable as more resistors are added in parallel, and then we state the effect on the dependent variable. In this case, the current increases. A better answer to that question would be to recognize that they increase proportionally. As we double the number of resistors, we double the current. So you could say also that the number of resistors in parallel is directly proportional to the current. Alright, 10.5.2, use the data given to calculate the voltage of the cell, and we're told to assume that the battery has negligible internal resistance. So we can choose any set of data. I'll answer by just using the first set. So we're assuming we have 2 resistors in parallel. And to work out the combined parallel resistance, we use our parallel resistor formula. 1 over R parallel is 1 over 10 plus 1 over 10. And so R parallel gives us 5 ohms. And now to calculate voltage, we use Ohm's law. V equals IR. The current is 0.3, that's given in the table. The resistance is 5, we've just calculated that. And so it gives us a total voltage of 1.5 volts.